Welcome to your Business Calculus Lesson 4.3 Part 1 on Implicit Differentiation. Okay, so consider x squared plus y squared equals 1. The the equation for the relation of the good old unit circle, it's not a function, but it would still be nice to be able to find the slope of the tangent line. Um, so, huh, we're going to have to think of another way to get the derivative of y with respect to x, even though we can't isolate y. So what we're going to do is we're going to start off by taking the derivative with respect to x of both sides of the equation. All right, so the derivative of the sum is equal to the sum of the derivatives. So I'm going to have the derivative with respect to x of x squared plus the derivative with respect to x of y squared, and that is going to equal the derivative with respect to x of 1. So now let's look. The derivative with respect to x of x squared, easy peasy, is using the product rule, is going to be 2x. And then we're going to have plus. Now, we know y is not some sort of constant that we have a weird symbol for. It has a relationship with x, but we don't know explicitly what that relationship is. So when we do the chain rule for y squared, because we know y has something to do with x, we're going to have to introduce another symbol. So first, we're going to do the derivative of with respect to y of our expression here. And so we're going to have 2y. And then the way we're going to express the derivative of y with respect to x is with this. It looks like dy divided by dx, and it's not. It's the derivative of y with respect to x. And if you want to say it real fast, sometimes people say dy dx. But what we're working with here is the derivative of y with respect to x. We're not sure what that looks like because we haven't written y in terms of x, so we're just going to put that right here. All right, so that's going to equal the derivative of 1 with respect to x. 1 is a constant, so its derivative is 0. Now, we want to get this derivative of y with respect to x isolated, so we need to move the 2x over to the other side of the equation, and then we need to divide by 2y. So we get the derivative of y with respect to x is equal to negative 2x divided by 2y, and so the negative 2's cancel. And so we get the derivative of y with respect to x is equal to negative x over y. Okay, so what that means is I can find the slope of the line tangent to this circle at any point. So if we did the 45-degree angle here, where we're at square root of 2 over 2, square root of 2 over 2, when we plug those in, we would find that our slope is equal to negative 1. Pretty cool. This process is called implicit differentiation. So whenever you're not able to write y explicitly as a function of x, we can still find the derivative of y with respect to x using implicit differentiation. You're going to differentiate both sides of the equation with respect to x, collect all the terms involving the derivative of y with respect to x on one side, and then factor that out and solve for the derivative of y with respect to x. So in a nutshell, differentiate both sides with respect to x, solve for the derivative of y with respect to x. Let's look at another example. We've got 2y equals x squared plus sine y. Well, we can't solve for y, so we're going to have to use implicit differentiation. So we'll take the derivative with respect to x of both sides. So for our 2y, the derivative with respect to y is 2, and then the derivative of y with respect to x, we're not sure what that is, so we'll write it symbolically as dy dx. And then we hop over to the other side of our equal sign. The derivative with respect to x of x squared is just 2x. And then we'll go to our last term, and we've got the sine of y. And so the derivative with respect to y is cosine y. And then the derivative of y with respect to x is just derivative of y with respect to x. Now, we want to get both of those dy dx terms on one side. So we've got 2 derivative of y with respect to x minus cosine y times the derivative of y with respect to x equals 2x. So we can factor out the dy dx out of both of those terms, and we get the derivative of y with respect to x times 2 minus cosine y equals 2x. And so we divide both sides by the 2 minus cosine y. And we have found our derivative of y with respect to x. Again, the process we used for doing that was to differentiate both sides with respect to x and then solve for your derivative of y with respect to x. Okay, guys, implicit differentiation is going to require a lot of practice for you to get really comfortable with it. So go ahead and print out that problem set and do the problems that you can, and then we will work together in class. Thank you so much for watching the video.